So this second video of my new format came out a bit faster than I expected. I thought I would create a video every week, once a week, of course, but I realized that 5-minute videos don't really take that much time to make, and also it would be better if I upload more frequently, especially in the first few videos, so that it's not as if you just watch one video and then wait a week for another video, especially with a content video. If it was some other type of video, then that would make sense. But if you're actually learning a subject, then it doesn't make sense to actually wait a week between every topic. So that's why I'm making this second video a bit quicker than expected, basically 5 minutes after I made the first video. But like I said in the previous video, and if you didn't watch it, go ahead. It's basically introduction to whole numbers. This is representations of whole numbers. Like I said in the previous video, I'm going to talk about the representations of whole numbers. There are 4 of them that you should probably know. Let's take that number from our previous video, 849. Now, how do we represent this? Well, this itself, like I said, is a representation. This is called standard form. And voila, standard form. Basically, it's written as digits, but in periods. So if you don't know what digits are, go back to the first video. I explained digits there. If you want just a brief introduction of digits, it's just the numbers on your phone keypad, like 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. There we go. That's digits. Periods, though, I haven't talked about that yet. Periods are basically groups of 3 values, and you've probably seen them before, especially when you're talking about large amounts of money. You've probably seen something like $1 million, right? Basically, everything between the commas is a period. So this is one period. It would be the ones period, because the lowest number there is a 1. This would be the thousands period, because this is 1,000. And this would be the millions period. Technically, of course, this would be 001, because zeros really don't give much value when they're in front of a number. Basically, they don't give much value. It doesn't change the number. So this entire block would be the millions period. And of course, there's billions and trillions and who knows what else. But that would be standard form. You write it using digits and periods. So for example, if I had a larger number like 21,611, this would be one period made up of 3 digits. This would be another period made up of 3 digits. But it's proper form not to write the zeros in the front, because then you can write infinite zeros and basically confuse your math teacher. But we don't want that to happen, because then they might give you a bad grade. Anyway, so you would just write it something like this: 21,611. So that's standard form. Now, there is also 3 other forms of writing it. And we have expanded form. And this one is basically you take a number in standard form. I like the number 849, so we'll stick with that. And you basically convert it to its place values. So the place values of a number are basically ones, tens, hundreds, thousands, 10,000s, 100,000s, millions, 10 millions, and I can keep on going. But it's basically each value increases by a factor of 10 when you go to the left. For example, this 9 right here is in the ones place. This 4 is 10 times that, would be in the tens place. Then 8 would be in the hundreds place. And then there would be a 0 in the thousands place, a 0 in the 10,000s place, and now I'm going off the screen, so I can't add any more zeros. Anyway, these are place values, just a basic introduction to place values. Basically, what we do in an expanded form is we write it based on place values. So we write 8 hundreds, so basically 8 times 100, and this little dot right here is times. We'll get into multiplication in a further topic, basically in 2 videos approximately. But this is 8 times 100 plus 4 times 10 plus 9 times 1. And then you can also write it as 800 plus 40 plus 9. And I could give you an example of a much larger number, like the 21,611 we talked about earlier in expanded form, but right now I'm trying to keep these as short as possible, and also it'll take a lot of space for me to write down. So for now, it's basically you take each value, each digit. Oops, I completely destroyed the 9. You take each digit, you multiply it by its place value. So 9 times 1, 4 times 10, 8 times 100, so on. And then you can write it in one of these forms. These both are expanded form. And I should probably write expanded form to just show you that this wonderful form is expanded form. Moving on. Oops. Let me get rid of these stuff. Then we actually have words. And I'm assuming most of you know how to do this because words is probably what you learned before pre-algebra, like in elementary school. You probably learned something like 849 would be, I'm not writing it out using a pencil tool. I'm just going to type it out because that takes less time. 849, probably something like this. And this would be in verbal form, or as some people like to call it, writing in words. So this is basically you take each digit and you sort of do expanded form, except you have to actually remember the names of the numbers. That's verbal form. And the last one we have is a number line. So a number line is basically this big line, and it has whole numbers on it. So you have, I'm just going to say the middle of the line is 5. So we start at 0, 1, 2, 3, 4, and so on, 6, 7, 8, 9, all of that. And you can write a whole number on a number line. 3, for example, you would mark it with a dot like this. If you had something like 849, you'd put 849, you would create a whole new other number line, put 849, and put the numbers that are close to it. This is a very bad number line, of course, because 850 on this side, 848 on this side, and you could put more intervals between those, 850 here instead of there, of course, but for these purposes, this is fine. This is a number line, and one last thing about number lines is order. So order matters. Basically, numbers on the right are greater than, and numbers on the left are less than. So basically, 5 is greater than 3, 1 is less than 3. So this is less, this is greater. And that's basically it for representations of whole numbers. To recap, I gave you 4 different methods of finding and representing a whole number: standard form, expanded form, verbal form, and a number line. Number line, you also have order, less than and greater than, but that's basically it. Next time we'll be talking about addition and subtraction, so tune in for some more pre-algebra. Until then, see you.